Hello and welcome. Today, we are going to pull back the curtain on the evolution of AI's brain. We're going to trace the incredible path it took from basically just counting words all the way to understanding the deep, subtle context of how we actually talk.
Look, this is the question on everyone's mind right now, especially if you're a data professional. With AI moving at lightning speed, how do you make sure you don't just survive, but you actually thrive? How do you secure your place in this new world? Well, the answer isn't what you might think. It's not about frantically chasing after the newest, shiniest tool. It's really about understanding the fundamentals. To truly make your career AI-proof, you have to get a handle on the architectural journey, the story of how these models learned to think in the first place. So let's start at the very beginning.
Okay, so think about the very first hurdle. A machine doesn't get English or Spanish or any human language. It's a world of numbers to them. So the first great quest, the first big challenge, was figuring out how to translate our words into a language that a computer could actually process. And the very first attempt was, brilliantly simple. It's called Bag of Words. The name is perfect because it's literally like you take all the words from a sentence, throw them into a bag, shake it all up, and then just count what you have. The order? Gone. The grammar? Totally ignored. It's just a word count. So how does this actually work? Well, it's a pretty simple three-step dance. First, you tokenize a sentence. That's just a fancy way of saying you break it into individual words. Then you build a master vocabulary, a big list of every single unique word you've seen. And finally, to analyze a new sentence, you just create a vector, a string of numbers by counting how many times each word from your master list appears. It's simple, it's elegant, and it has one massive giant flaw. And here it is. This is the fatal flaw. To a bag of words model, the sentence, "the dog bit the man," is identical, 100% identical to "the man bit the dog." Why? Well, because they have the exact same words, the same counts. And this just perfectly shows the problem. A bag of words model has absolutely zero understanding of context or meaning. So you can see how this was a huge problem, right? For any real-world use, this was a total dead end. We needed a giant leap forward. We needed a way for machines to get that words have relationships, that they have neighbors with similar meanings. This was the next critical step in the evolution of AI thinking. And that leap came in the form of something called word embedding, with the most famous model being word2vec. The core idea here was to stop just counting words and start mapping their meaning. By turning each word into a complex vector, a long list of numbers, the machine could finally learn things like, king is to queen what man is to woman. It was starting to grasp relationships. So how in the world does it do this? Well, under the hood, word2vec is basically evaluating each word across hundreds of different abstract features or dimensions. You can think of them as questions like, is it an animal? Does it have a tail? Is it related to royalty? Is it a concept? And by plotting the answers to these hundreds of questions, it creates a unique numerical fingerprint, a vector, for each word, placing it on this incredibly rich, multi-dimensional map of meaning. But language, it's a tricky beast. A word's meaning can completely change based on the words around it. And word2vec, for all its cleverness, still had this massive blind spot. It would give the word fan the exact same vector, the same numerical meaning, in both ceiling fan and big fan of your work, totally missing that crucial change in context. Now, solving this context problem wasn't just some small academic exercise. This was everything. This was the key that would finally unlock the kind of AI we all interact with every single day. And that brings us to what is probably the single biggest breakthrough in modern AI. This was the true aha moment. It all kicked off with this now legendary research paper from 2017 with a title that sounds almost bold. Attention is all you need. It introduced a groundbreaking mechanism called attention, which, in simple terms, lets a model weigh the importance of different words in a sentence when it's interpreting any single word. It finally gave AI the tool it needed to truly understand context. This attention mechanism became the absolute core, the beating heart of a revolutionary new kind of architecture, the transformer. And folks, this is the blueprint that powers virtually all the AI we use today, from your search engine all the way to ChatGPT. So the transformer architecture kind of split into two main families. On one side, you've got decoder-only models, like GPT. They read text from left to right, which makes them absolutely incredible at predicting the next word. If you're building a chatbot, you need a generator. On the other side, you've got encoder-only models, like BERT. These retext in both directions, forward and backward, to get a much deeper, richer understanding of the context. If you need to analyze a bunch of customer reviews for sentiment, you need that deep understanding. Okay, so we've taken quite a journey here, from simple word counts all the way to these complex architectures that get context. But let's bring it all home. How does knowing all this make your career AI-proof? Let's connect the dots. When you lay it all out on a timeline like this, the whole story just clicks. We went from machines just learning to count words to them learning that words have meaning. And then, the big one, they learned that context changes that meaning. And now today, with transformers, they're mastering that context for both generating text and understanding it. This isn't just history. It's the core logic of all modern AI.
So here's the bottom line. Why does this matter for you as a data engineer? Well, first off, when you get this evolution, all that jargon, words like embeddings and attention, it's not intimidating anymore. You get it. It also gives you the fundamental knowledge you need to actually build and use these modern AI systems effectively. It's the difference between just using the tools and truly understanding how they tick. And that right there, that is the core skill for making your data career AI-proof.
So, we've covered the how and the why. You now have the architectural blueprint for modern AI in your head. The only real question left is, what are you going to build with it? Thanks for joining us.